So in this video, let us understand how bunching is happening in a two-cavity klystron. So in the last video, I told you that the frequency of the bunches is same as the frequency of the input signal. So what does it mean? It means that for every one cycle of the microwave, one bunch is formed. So how is that formed? Please understand here, we have something called as the bunching limit. So what is the bunching limit? The bunching limit is from the negative peak to the positive peak. So please recall that, so at the negative peak, see the right hand wall of the buncher cavity is highly negative. So because of its highly negative, when electrons is approaching towards this buncher cavity, they feel a retardation, meaning to say their velocity is the least, okay, at the negative peak. See, that's what it says, that it is slower. Now, when so how is the voltage changing? The voltage is going from negative to positive. So when the voltage or the potential difference becomes zero, the electrons cross this gap without getting changed velocity. The velocity is not getting changed. Now when you look at the positive peak, what happens? Here this end is highly positive, the highest positive value. So when electrons are approaching here, they are going to be moving very fast. So in this limit, what happens? All the electrons that has crossed the gap from the negative peak to the positive peak, there is a probability they are all going to form a bunch. So let me give you a small analogy how to understand. Say your friend has left, okay, he has left before you walking. He has left you and he has gone walking maybe 5 minutes ago, okay. You want to catch up with him. So how will you go? You will definitely go on a bike. So your friend who went earlier is going slower. And if you want to catch up with him, you are going faster on a bike. So what happens? There is every possibility that you who is fast can catch up with the slower one who has left earlier. So all the electrons that has left the gap of the buncher cavity from the negative peak to the positive peak have the probability of forming a bunch. Okay. Now let us see what happens from the positive peak to the negative peak. Okay. So is there a probability of electron bunches here? Let us see. So let me tell you the same analogy. Suppose your friend has left early on a bike. Okay. And if you are going and trying to catch up with him going walking, can you ever meet your friend? So that is quite impossible, isn't it? Now see here, this is early in time, okay. So you have an electron which is moving very fast, but with passage of time the velocity is reducing. So is there a chance for the electrons which is left the gap from the positive peak to negative peak to catch up with each other and form a bunch? No. So please understand, that's why I told you in the previous video that in one cycle, let me consider this as one cycle. From this positive peak to this positive peak is one cycle. So there is no formation of bunches from this. Here no bunches can be formed. Okay. Bunches can be formed, or the probability of forming of bunches can happen only from the negative peak of the input voltage to the positive peak of the input voltage. So this is called as the bunching limit, okay. And this happens only every once in a cycle. That's why I told you that the frequency of electron bunches is same as that of the frequency of the signal that is applied to the buncher cavity to be amplified. I hope you understood the bunching process.